The metric system, which is also called the SI system, is pretty much the most commonly used measuring system by everybody except for the United States. And one of the cool things about the metric system is it's based upon powers of 10. So when we want to convert units, it pretty much involves us moving the decimal. So a little bit of background on the metric system and how it ties into the United States. So in 1866, the U.S. Congress actually legalized the use of the metric system throughout the United States. Now, we also had the U.S. customary system, but the metric system was also approved for use. By the 1970s, the U.S. was pretty much the only non-metric industrialized nation remaining in the entire world. So because of that, we have some goofy things that go on with our measuring. Like our football fields are measured in yards, while if you're in a race, you're usually running the race in meters or in kilometers, such as running a 5K. Even in an automobile, its power is measured in horsepower, which is foot-pounds per second, but that same engine's displacement is measured in liters. Or sodas are measured in 12 or 16-ounce bottles, but if you want to go to a bigger bottle, it's measured in 2 liters. So we kind of have all these scenarios where we're going back and forth between the U.S. customary system and the metric system. Now, there was the idea that we should maybe get with the times and be like everybody else. And in 1975, President Gerald Ford signed the Metric Conversion Act, which declared metric was the preferred system of weights and measures for United States commerce and trade. But to have companies use the metric system was voluntary. And actually, there was small activist groups that advocated against metricating. So there was actually some pushback in small pockets of society. And because of that pushback and the fact that it was only voluntary, it wasn't mandatory for people to go to metric, it kind of lost its steam. And a few years later, President Ronald Reagan actually defunded the metric board. That was pretty much the last major push in the United States to have the U.S. go metric. A poll as recent as 2016 found that only 32% of Americans wanted to go metric. And some of the biggest reasons in the United States that we won't go metric, opinions vary, but most people come to the fact of thinking that it has to do with money or either time to educate people on the metric system, or just maybe some good old-fashioned American stubbornness. Whatever the reason, we have both a metric and the U.S. customary system in the United States, so we, as fun participants in this country, we get to actually learn both systems. Alright, so let's look at some units in the metric system. So if you want to measure length, typically in the metric system, we're going to use the meter, which is abbreviated M. If you want to measure mass, the basic unit in the SI system is the kilogram, which is abbreviated kg. We want to measure time, that's going to be in seconds, S. If we want to measure the electrical current, it's measured in the ampere, which is sometimes just referred to as the amp. Its SI abbreviation is capital A. So one of the things to notice when we're looking at these SI abbreviations is some of them will be lowercase and some of them will be uppercase, and it does matter, so we do need to pay attention to which is which. Temperature in the SI system is measured in kelvins. The SI abbreviation is capital K. Light intensity is measured in candelas, which abbreviation is CD. And molecular substances are measured in moles. Its SI abbreviation is MOL. This part of the metric system is referred to as the base units, because none of these units can be referred to or expressed in terms of any of the other units. So they're kind of fundamental units for talking about whatever that attribute is that we are trying to measure. Other commonly used units in the metric system are the liter, which is abbreviated for capital L, And the cubic meter, which is abbreviated with M with a little 3, kind of like an exponent on there. We would verbally say that as cubic meters. Both of those are used to measure volume. We typically use the liters when we're measuring liquid for volume, and the cubic meters for kind of standard volume measurements. Now you might have noticed that for the meters, how I have it spelled right here is M-E-T-R-E, and liter is spelled L-I-T-R-E. These are the internationally recognized spellings for these units, but you know, sometimes you might see this as the meter is M-E-T-E-R, or the liter is L-I-T-E-R. Both spellings are used in the United States, so don't be distracted if you see kind of a spelled a little bit backwards. That's just the internationally recognized spelling. All right, so other units out there in the metric system, if you want to measure area, we can measure that in the basic unit of the square meter, which would be M with a little 2 for the exponent after the M. Force is measured in newtons, which is capital N. Speed can be measured in meters per second, which is M and then slash and then an S for meters per second. Energy is measured in joules with a capital J for the abbreviation. Power is measured in watts with a capital W for the abbreviation. And then angles in the plane are measured in radians, whose abbreviation is RAD. There are other units floating around in the metric system, but these are the ones that we want to kind of recognize, at least for right now. Right, so one of the things that we should be able to do in our metric system is we should be able to work with the prefixes with the units in order to write a certain unit of measure. Now, from your base unit, from whatever you're measuring in, so maybe, let's say, just for instance, we're measuring things in meters. If we want to measure larger units, which always go up by power of 10, their prefixes would be deca, D-E-K-A. Sometimes it's spelled D-E-C-A. Its abbreviation is D-A. Hecto, which would be 100 meters or 10 squared, its abbreviation would be H. Kilo, which is 10 to the third power, so if I was thinking about this in terms of kilometers, 1 kilometer has 1,000 meters. The abbreviation for kilo would be lowercase k. And then after that, we get new prefixes every time we jump up to the next power of 3. So, for instance, you can see there's a power of 3, and then we're going to get new prefixes at power of 6, power of 9, power of 12, and so on. So when we're at 10 to the 6th power, the prefix for mega is capital M for its symbol. 10 to the 9th power, its prefix is giga. Its symbol would be capital G. 10 to the 12th power's prefix is tera, which is capital T. And then it keeps going on, bigger than that. You can look online if you want to find other prefixes that are bigger than tera. So for example, if you wanted to go bigger than that, we've got peta, which is capital P for its prefix, exa, and so on and so forth. Okay, so this can keep going bigger than that, and we again get a new prefix every time we jump up to another 3 in the exponents. So 10 to the 15th power, 10 to the 18th power, and so on. From your base unit, if you wanted to get into smaller units, so decreasing it by a power of 10, we also get prefixes that way. So deci would be then a tenth of your basic unit. Okay, so deci's prefix would be D. All right, so what's going on here? If you, for instance, had 1 decimeter, that would mean that you have a tenth of a meter. After that would be centi, whose abbreviation is C. Milli, whose abbreviation is M. All right, so that would mean that you have 1,000th of a meter, or in other words, there's 1,000 millimeters in 1 meter if you wanted to connect it to an actual unit. After that is micro. Now this one's a little bit weird. We actually pull a symbol from the Greek lettering system. So it kind of looks like a U with a little tail on the front of it. So this is a Greek letter. It's the Greek letter, we verbally say it mu. But when we read this in the metric system, we say micro when we see this symbol. Nano, whose abbreviation is lowercase n, and pico, whose abbreviation is lowercase p. So again, going down into these smaller units, we have prefixes for what would be in the tenths, hundredth, and thousandth spot, but then after that we jump and we get a new prefix every multiple of 3 going downward. Meaning you get new prefixes at -6 power, -9 power, and -12th power. And then it can keep going down here. This can keep going down in prefixes for smaller and smaller one every time you get to another jump in the power of 3. So for instance, after pico, the next one after that would be femto, and then atto. So we can keep going. And again, you can look those up. Those are a little bit more obviously uncommon, but this prefix system just kind of keeps on going in both directions. All right, so one of the things that we want to be able to do is take our units and take our prefixes to not only take a measurement and write it with the abbreviations, but also be able to see abbreviations and understand what units we're looking at. So as a couple of examples then, if I had 19 hectoliters and I wanted to write that in abbreviation, so I would be 19 for hecto. Its abbreviation would be lowercase h, and then for liters, its abbreviation is capital L. So 19 hectoliters would look like 19 HL, lowercase h, upper capital L. 5 megawatts, so I would have 5. Mega as a prefix would be capital M. Watts as a unit would be capital W. Okay, now seeing abbreviations, being able to go back and understand what you're looking at. So if I have 18M, and I wanted to write that out, that would be 18 meters. Now, just to be very clear, M is for meters, MI is the abbreviation for miles. Okay, so we need to be very, very clear when we're looking at that, if it's just M or MI. If I have 24 PS, what am I looking at there? So that would be 24. P as a prefix would be pico. And then S as a unit would be seconds. So this would be 24 picoseconds. Now, it's just a really quick review. What was the basic SI unit for measuring length? Do you remember? It is the meter. Very good. All right, so the basic SI unit for measuring length is the meter. Basic SI unit for measuring volume. Well, volume is not considered to be a basic unit. It's not a fundamental unit that no other unit can be derived from. So maybe we'll just ask, as opposed to saying basic, we'll say what, and there's actually 2 of them, so we'll say what are the common SI units for measuring volume, and there are 2 of them. Do you remember what they are? All right, so it's the cubic meter, and that's kind of the standard one, measuring volume in little cubes. Or if you're measuring liquid, the common measurement for volume would be in the liter. Okay, those aren't considered to be basic units because both of those are expressed in terms of other units in the metric system. We'll talk a little more about the liter and how that is considered to be what we call a derived unit a little bit later. What's the basic SI unit for mass? Do you remember? And this one's a little bit goofy. This one is the kilogram. All right, so it's not just the gram. because a gram is actually very, very small. So the basic SI unit for measuring mass, this is the only one that has a prefix on it as part of the basic unit. And then, do you remember what the basic SI unit is for electrical current? They are the amps or the amperes. And its abbreviation is capital A. Right? So that was the introduction to the metric system.